Now, after black holes, another concept which is very, very important from examination perspective is the concept of gravitational waves. If you look at the past papers, you will see that last 6-7 years, there have been not less than 3 to 4 questions that have been asked just from different concepts related to gravitational waves. What's the reason behind it? The reason is that gravitational waves, as theory, again, as a part of general theory of relativity, it was predicted there that something like this should exist, that this should be a known phenomena. But gravitational waves, a lot of research happened, a lot of studies happened, but were never detected. But then the things changed when we detected the first gravitational wave. And with the detection of first gravitational wave that just happened 6-7 years back, this is something that changed the entire course of the field of study of gravitational waves. So first of all, let's try to understand what is the meaning of gravitational waves, and then we'll look at some of the developments that have happened with respect to gravitational waves. Now, first of all, when we talk about this term gravitational wave, the name itself suggests what exactly it should be. Gravitational waves, meaning waves which are being generated because of gravitation. Because of the phenomena of gravitation, waves which are being generated in the space time. Now, space time, what is space time? No need to go into the physics and the details and the technicalities of it. Just understand this. When we try to conceptualize space time, you simply have to think of a football goalpost, a net, football net. What do you see in a net? If somebody kicks a football towards the football net, what will happen? As soon as the football hits a part of the net, a wave will be generated from there, right? A wave will be generated from there, and it will keep on propagating towards the sides. This is something that will happen, right? And as it goes towards the sides, this wave starts to become feeble, right? It will not remain as strong as it was at the point of the impact of the football, correct? So this is something that we observe. Just imagine a football net where somebody has kicked a football, a goal has been scored, and at this point of time, wherever the impact of the football happens, a wave generates from there. And as the wave propagates towards the sides, towards the corners of this net, you will see that this wave has now started to become weak. Something similar happens in the space time as well. Whenever something happens in the universe which is very energetic, which is very violent, or something that has a huge amount of energy associated with it, all these kind of phenomena will always have gravitational waves associated with them. Meaning what? Whenever these kind of phenomena happen, they distort the space time. They distort the space time in a similar manner as the football distorts the football goalpost. Something similar happens, as you can see in the picture also that you have on your screen, that at the place where you have a massive object, here we have taken the example of earth, but normally that will not happen with the earth, it will happen with very energetic things. So this will distort space time. So earth being massive, not as massive as some of the other phenomena, for example black holes we discussed, the mass of black hole is much 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 larger as compared to the mass of the earth. So that's why the phenomena of gravitational waves will be seen whenever you have black holes. So with black holes, definitely there are possibilities that gravitational waves can be generated from there. So whenever you have anything which is massive, it will distort space time in this manner, and from here we see that waves are generated. So very violent processes, very energetic processes. For example, if you talk about collision of black holes, or even merger of black holes, collision of stars, or even the very formation of the universe, right? So all these have been very highly energetic phenomena, all these have been very violent phenomena, and that's why whenever things like these happen, there will be gravitational waves that will be generated from there. So this is something that was predicted almost more than 100 years back by Albert Einstein in his general theory of relativity, but we did not detect any gravitational wave. And then finally few years back we detected the first gravitational wave, and then after that we have seen that it has become something of an active research, a lot of studies happening, a lot of new development happening, a lot of new projects being taken in the field of gravitational waves or detection of gravitational waves. So this is simply what it means. Waves which have been generated due to gravitation, the waves which have been generated in the space time because of the phenomena of gravitation, something that will happen whenever you have very highly energetic processes happening somewhere in the universe. Gravitational waves are the ripples in the space-time whose existence was predicted by Albert Einstein in his theory of relativity in 1915, caused due to violent and energetic events like collision of black holes, supernova, collision of neutron stars, etc. And these waves travel at a speed of light, carrying the information about the origin and the nature of gravity at that point of time. So that's why we want that we are able to detect gravitational waves that might have been formed at the time of the birth of the universe, so that it will give us some hint about the birth of the universe and how exactly the entire phenomena of the birth of universe was happening. So it might give us more clues, more insights towards that formation. Now there's one thing you have to understand, that detection of gravitational waves has not been easy, and it will not be easy. It has taken almost 100 years for us. 1915 theory of relativity came out. 2015 the first time we detected gravitational waves. The main reason behind it is gravitational force. The force of gravitation is a very weak force as compared to the other forces in nature, whether you talk about the nuclear forces or electromagnetic forces. Compared to them, gravitational force is very, very weak. And that's why gravitational waves, although they are emitted from all these energetic processes, they are still very weak. And that's why most of the gravitational waves that will be formed, they will die down before they reach the surface of the earth. For example, the first gravitational wave that was detected, it was a gravitational wave that was produced from merger of two black holes almost 1.3 billion years ago. And it was a phenomena which was very energetic, huge amount of gravitational force associated with it. And by the time it reached here, it was a very weak gravitational wave that we detected. But thankfully, we did detect it. Now we have this observatory which is called as LIGO, Laser Interferometer Gravitational Wave Observatory. LIGO. This is the observatory which had detected the first gravitational wave. So what exactly happens in LIGO is that you have kind of two arms, as you can see in the picture itself. Now these two arms, normally there are beams which are going and coming back. The beams are going and coming back, and both these arms being equal in length, it takes the same amount of time for these beams to go and come back. Whenever they detect a gravitational wave, what happens is that one of the arm lengths becomes shorter and the other one becomes longer. So in this case, what happens is that this wave, this beam that is going, will come back quickly to the origin, and this wave will take higher amount of time to come back to the origin. And that's why this will give a hint to the scientists that there is a gravitational wave that was passing by this observatory, and that's why they were able to detect it. That's why the arm length changed, and the time that it takes for the beam to go and come back changed. So this is a hint that they get, and then they understand that there would have been a gravitational wave, and then the detection happens from there. No need to go into the details of it, just understand on the surface this is what happens. So this is LIGO. Just know that LIGO is where gravitational wave has been detected for the first time. The first gravitational wave that was detected, it was detected at LIGO. At the same time, India also is developing something which is known as Indigo. Indigo is a consortium where we have a collaboration with LIGO and other scientists who are involved with the study of gravitational waves, and all the Indian physicists who are also involved in the study of gravitational waves. So we are building one more observatory in Maharashtra where this will be called as Indigo, a project where LIGO also is involved, and we are taking help from LIGO in building it out. Now after that, there are others also. For example, you have another project which is called as Project LISA. This is known as Project LISA. LISA stands for Laser Interferometer, same as what you have for LIGO. Space Antenna. S stands for space and A stands for antenna. So LISA stands for Laser Interferometer Space Antenna. Now, what is this LISA? LISA is nothing but another gravitational wave observatory. Only difference being that when you talk about LIGO, LIGO is placed on the surface of the earth. It is located in the USA. When it comes to LISA, LISA is a setup that has been built in space, that has been taken to space for the observation of gravitational waves. Now, this LISA project had started a long time back, but at the same time, we see that there have been many changes to it. For example, the original LISA project that we have, this was supposed to be a project which is in the shape of an equilateral triangle instead of this being two arms of a figure. Equilateral triangle where you have a test mass placed at the center, and this will be the one which will help in detection of gravitational waves. Now, this arm length initially was supposed to be approximately 5 million kilometers. 5 million kilometers was supposed to be the length of the arms of this equilateral triangle. But then there were certain changes that were made to this particular project, and this arm length was then reduced to 1 million kilometers, approximately 1 to 1.5 million kilometers, and the name also changed. This name was then changed to ELISA, where E basically stands for evolved. This was named as evolved LISA. So you might come across terms like LISA, ELISA, or even another one which was called as LISA Pathfinder. LISA Pathfinder is nothing but an experiment that was taken before the original LISA project. An experiment where we were just testing out whether LISA can work properly or not. Are all the components in place? Are all the sensors in place? Is everything that was supposed to be designed have been designed properly? So this was the experiment that was taken. LISA Pathfinder was the experiment that was taken before the original LISA project or the evolved LISA or the ELISA project. So just understand that this is also a gravitational wave observatory, but a gravitational wave observatory that has been taken into space. Now the question is, why to take it into space? Why to complicate the things? The reason for it is the gravitational force. When you are on the surface of the earth, you also have very strong gravitational force which is being exerted by the earth. Not only the earth, you also have the moon, you also have the sun, and because of that you have gravitational force coming from all these different celestial bodies. So because of that, it does pose some problems, some technical challenges, because of which it was thought that let's take this project LISA, to space, where the force of gravitation and other kinds of distortions or noise that would be there on the surface of the earth is not present, so that we are only acting under the influence of the force of gravitation. So that was the whole idea behind taking this observatory to space, and this was called as LISA, and then at a later stage it was called as evolved LISA or ELISA. So this is it about the gravitational waves.